Welcome. We want to look at an example of function composition and looking at the domain. Now, this actually contains two examples here because we're going to take the function f, which is the square root of x, and g of x, which is x squared minus 4, and we're going to find both f of g of x and g of f of x, and of course the domain of each. So what we want here is, let's see, it says f of g first, and sure, let's take a look at that one. G of f is the more interesting example, but we should consider both here. So let's go with f of g of x. This is going to be f of g of x. And let's see, f is the square root function, so we're looking at the square root of g of x. And g of x is x squared minus 4, so this is the square root of x squared minus 4. Excellent. Now, really quickly here, we want to recognize that the square root does not distribute over the square root does not distribute over subtraction. So this is not equal to x minus 2. We cannot take the square root of x squared and the square root of 4. That does not work. We cannot do that. I only mention it because a lot of people do that, unfortunately. So we have this presentation, and that is it. All right. Now, what I need to do is in order to find the domain, this is actually, so I said that the only thing we're going to need to answer these questions are tools that we already have. And here I'm going to call myself out and say I'm a liar. And that's because I've chosen a problem that actually uses things from later in this chapter. But the point is that later in this chapter, you could encounter this question and you would have to be able to answer it in this way. So what I want is to start with the domain of the innermost function. So I want to start with the domain of g of x here. For the domain of g of x, x squared minus 4, this is all real numbers. There's no radical to worry about. The even root of a negative number, there's no division to worry about division by 0. For the domain of f of x, what we're going to have is we are going to have, let's see here, we do have the radical, right? So we actually just need from 0 to infinity. This is a pretty straightforward, very simple function. Don't really need much work to be able to show that. Don't need any work to show that in this case, right? We're just looking for what's underneath the radical to be greater than or equal to 0. Oh, okay, x greater than or equal to 0. Now I take these two things and I sort of combine that information. I can plug anything I want into g of x, but what I need is g of x to be greater than or equal to 0. In this case, that gives us x squared minus 4 greater than or equal to 0. And now we've encountered something that we haven't seen before. This we will learn how to better address later in this chapter, actually, pretty quickly here. So you'll be able to complete this problem on your own a little bit later on. So a little bit of work for later section. So a nice little preview of the types of problems that you could encounter. But this is going to give us, we need x less than or equal to -2 or x greater than or equal to 2. When we solve that inequality, it's going to result in this as our solution. From here, actually, you know what? It'd probably be pretty easy to get this idea, right? If I were to add 4 to both sides in this case, I would get x squared is greater than or equal to 4. Now, of course, any number less than -2 and any number greater than +2 are going to satisfy that. So the formal work that we would see later, right, we can do that later. For now, it's a pretty basic idea. We should understand that this works. All right, this gives us the solution set for the domain of the composition, right? So I can plug anything I want into G. What's the restriction on that? Well, the restriction is that we need this. Where did this restriction come from? That came from the requirement of recognizing the domain of G, and we need, the domain of F, and we need G to belong inside of that domain. That is, G of X needs to be greater than or equal to 0. So the domain of the composition, F composed with G of X. This is going to be from negative infinity up to -2. Join that with 2 to positive infinity. Now, could we have found the same domain by simply looking at what the composition is? Yes, we still could have done that. But now we want to consider an example where that would not work, okay? Where that would not work. So what I'm going to do is I'm going to consider G of F of X. Now, since G is on the left, this is going to be G of F of X. And we are going to take the function G, which is x squared minus 4, and we're going to plug F into it. So I'm taking F of X, and I'm squaring it, and then subtracting 4. F of X is the square root function. So I'm taking the square root of X, and then I am squaring it, and then I'm subtracting 4. So this just results in x minus 4. Right? There's no issue with squaring the square root. So this is just fine. The square root of x being squared is indeed x. Now, what's the domain of this? All right, so is the domain from negative infinity up to positive infinity? That is the question. We composed. What's the domain of this result? Well, I can plug anything I want into that. No big deal. But is that truly the domain of the composition? So in order to answer that question, we first find the domain of the innermost function, which is f in this case. The domain of f we already found above is 0 to infinity because it's the square root function. Right? The domain of this function is from 0 to infinity. And that's the thing that we're beginning with, right? We're going to take that as our largest possibility, and then we're going to remove anything that might cause concerns. So now I consider the domain of G. The domain of G is all real numbers from negative infinity to positive infinity because it is polynomial, x squared minus 4. No radical, no even radical of a negative number, no division to cause division by 0, plug in whatever I want. So whatever I get out of F, can I plug it into G? Of course I can. So the domain of the composition, so this is no restrictions, no further restrictions. But this does give me a domain of G of F of X to be just that of the domain of F, which is 0 to infinity, not all real numbers. The domain of the composition in this case is from 0 to infinity. That's the only things I'm allowed to plug into there because they are first being plugged into the square root function, right? We need to understand that in order to plug into the composition, I first have to be able to plug into F. If I want to plug into F, I have to be a non-negative number, even though the end result is going to be just x minus 4. All right, thank you for your time. Let me know if you have any questions about composition and finding the domain of those compositions.